Hello everyone, I am Karan Mashru. Welcome to this video. In this video, we are going to discuss solution of the problem of the day, that is delete a node in single linked list. First of all, let us start by understanding the question. What does question say? It says that given a singly linked list and an integer x, delete the xth node from the singly linked list. So basically we are given a singly linked list and suppose x is equal to 3. So in that list, starting from the head pointer, we want to delete the third node if x is equals to 3. Okay, and modify the linked list. If we look at the example, if our input linked list is 1, 3 and 4, and if x is equals to 3, means I want to delete the third node, so I want to delete this node, so the modified linked list would be 1 and 3. If we look at the second example, if my input linked list is 1, 5, 2, 9 and x is equals to 2, it means that I want to delete the second node. So if I delete this, my modified linked list would be what? 1, 2 and 9, because node having value 5 is deleted. Okay, our task is to complete this function, which takes two arguments, the address of the head of the linked list and an integer x. Now we are given a singly linked list, so how can we access it? Through the head pointer. So in the input we are given the head of the linked list and the integer x, that is the number of node which needs to be deleted. The function returns the head of the modified linked list. So after deleting the xth node, our linked list will get modified, so we want to return the head of that modified linked list. Okay, and the constraints are given here. The number of nodes can go up till 10 to the power 5, and x, that is the number of node to be deleted, lies between 1 and n. Okay, obviously it should lie between 1 and n only. So now if we think about solving this problem, then what we can do is, suppose we look at these two examples. So suppose this is my linked list and this would be the head pointer, okay, which would be given to me in the input, and x is equals to 4. So I want to delete this node. Okay, so what I can do is, see, I have the access to the head pointer. Using the head pointer, I can keep traversing up till the node just before the node to be deleted. So for example, if I take a temp variable in which I'll store the address, so suppose temp is equals to head initially, so temp will point here. Now I'll keep traversing on the front end side, on the forward side, up till the node just before the node to be deleted. Okay, so I want to delete this node, so I'll traverse till here, so my temp pointer will be pointing till here. Okay, then I'll stop. Okay, how we will implement it, we will look in the implementation. Okay, so my temp pointer is here. Now understand one thing, if I want to delete this node, so what I can basically do is, I want to keep 5, right? So after 3, 5 should come. So basically temp is pointing to the node having value 3. So temp next, that is this pointer, should now point to this. So can I say temp next is equals to, this is temp is pointing to the node just before the node to be deleted. So temp next, so the next node after this is not this but after that. So temp next is equals to temp next. Can I say this? So basically my temp was pointing till here, this is temp next. I said temp next, that is this pointer, is equals to temp next. Now what is temp next? This pointer. So basically this will become equal to this, so this will be joined here. So my modified linked list would be what? It would be 1, 2, 3, and this pointer will now directly point at what? 5. So 4 is removed from the linked list, our linked list is modified. What else you can do? You can take a pointer to this, you can maintain a pointer to this before changing this, and then you can free that pointer. Suppose the name of that pointer is temp1. So basically the memory occupied by this node would be freed up, and we have already modified the linked list. Our head pointer will remain the same, so we will return that head pointer only. So to conclude, what I can do is, if I want to delete the xth node, I can traverse up till x minus 1th node and then change temp next equal to temp next. Okay, so that node will be removed from the between, and I can also free the memory occupied by that node which is to be deleted. One corner case can be what? If I want to delete the first node, suppose my linked list is 1, 2 and 3, and if x is equals to 1, so I want to delete the first node only, right? Now here what we were doing, if I want to delete 4th node, I was traversing till 3rd node, but here we want to delete first node only, there is no node before it. So what we can simply do it, we can say head is equals to head next in this case. So what will happen? This is my head pointer. It will point to head next. So it will go here. So my modified linked list would be what? 2 and 3. This would be the head pointer, the new head pointer, and I'll return this. Okay. And what I can do, I can take one pointer pointing to this and free up the memory like how I did here. Okay. Now let's look at its implementation. So now if we look at the actual implementation, so what I have done is I have taken one temporary pointer and I have initialized it with head of the given linked list, and I have taken one more and initialized it with null. Okay, I have taken one variable c is equals to 1, which will basically help us in traversing up to the node number x minus 1. Okay, first of all, if x is equals to 1, so if this is the case that I want to delete the first node only, then I'll say head is equals to head next. So my head pointer will start pointing here. So my new linked list with the help of the head pointer would be 2 and 3, and temp is pointing towards head. So temp is still pointing here. So what I can do is I can free that memory. So this memory would be freed up. Okay, this would be freed up, and we will get the new linked list and will return head. So this case is covered. Otherwise, what we need to do is we need to traverse up till the node just before the node to be deleted, right? So suppose this is the case, x is equals to 4. So I want to delete this node. Okay, so I need to traverse till here. Now see, c is equals to 1 basically tells me that I am at the first node and my temp is pointing here. I am writing it as t. So for c is less than x minus 1, what is x? X is 4. So 1 is less than 3 because x minus 1 is 3. Yes, then temp is equals to temp next. So temp will go here. Now c will become what? 2 because c plus plus happens. 2 is less than 3. Yes. So temp is equals to temp next. So temp will be pointing here. Now c will become 3. 3 is less than 3. No. So I'll come out of the for loop. Where is my temp pointing? To the node having the value 3, which I want to delete. I want to delete the fourth node. So my temp pointer is pointing to the node just before the node to be deleted, right? Now what I need to do? First of all, I'll store the node to be deleted. I will store the pointer of that node. So temp1 is equal to temp next. So this is temp. So temp1 is equals to temp next. So temp1 would be pointing here, right? Now temp next is equal to temp next next. So this pointer will go from here and point here. So now 4 is removed, our linked list is modified, and I'll free up the memory occupied by temp1. So this memory would be freed up and the head would remain the same. Your head is not modified, so I'll return the head. What would be the time complexity? Time complexity would be big O of n as we are traversing the list. And what would be the auxiliary space? The auxiliary space, if we look here, we are only taking some variables, we are taking nothing else, right? So the auxiliary space would be constant. I hope you have understood it. Now let's submit this code. So let's submit it. So we have solved this question successfully. I hope you have understood this solution completely. Thank you.